The reason I'm kind of starting with this talk is that during some of my time at Puppet, I worked on agent applications. And when Nano Server first became a public idea from Microsoft, I was pretty interested in it. I've done some side projects tracking the development of this and trying to get our applications working on it. I'll be talking about Nano Server, some of the techniques I've gathered from working with it and experiences of kind of working through it as it was a technical preview and developing. It's been a fairly new and radical departure from trying to work with previous Windows operating systems. And it has a lot of, there was a lot of improvement during the technical preview process. Made a very interesting time to try and build things on it. What I'm hoping out of this, though, is that I'll get some people interested in Nano Server and maybe want to experiment with it, try and help develop some of the tools around it. So I'll be talking about a bit more about what is Nano Server, what are some of the things you can do with it, some of the limitations, because it is a large rethinking of how to run Windows. A couple of ways to get started with Nano Server, and where does Puppet fit into that right now? So first, what is Nano Server? I'm not an editor in a browser. I kind of wish it was at some of the times, or I kind of wish I had had this while I was working on it. Command line text editing is not a thing that you'll get yet. But it is a lightweight Windows server. So this is one of the graphs I've found floating around. It pretty much strips out the desktop experience, graphical shell, most management tools, bringing it down to just a 64-bit kernel, PowerShell, and the ability to add server packages as you need them. What that comes with is a greatly reduced disk space requirement, reduced memory usage, and it brings a reduced attack surface to protect against. It's also a much faster virtual server. So it'll boot up in about 3 seconds. These are some preliminary results. I think in the final one, it's just a tad slower as they added some extra things. But reboot in around 10 seconds. It comes in at can start at a 400 megabyte image. And part of that is also patching it is a lot faster. There's generally a lot less to patch in the first place, but all of those things kind of add up to that. That makes it a much nicer operating system to work with when you're in a virtual environment or working with containers. So why do I care? This is somewhat personal, but also just different ideas of what can work right now. So some of the core Windows Server things are still available on Nano Server. You can run an IIS server. You can run ASP.NET 5, a file server, DNS, DHCP. It can also host containers and Hyper-V images. So you can run a Nano Server container hosting Nano Server containers. And as such, Docker is one of the ways to do that, or is one of the ways of managing that. It can also make a good compilation and test server. So most of my interest has been in building faster and lighter test servers for RCI systems. I'm also, AppVeyor potentially, I think will eventually want to look at this. It would probably greatly reduce their hosting bills, among other things. So it'd be, I imagine that there are going to be a number of areas around CI where this moves forward. But this talk is more about the journey. I don't have it in CI yet. A lot of things, it's a young project. It's still developing many of the features. And so there are a number of projects that are having to make fixes to work with it. Things like Packer and Vagrant that you might use as part of a tool set. The Puppet itself, of course. It's also rethinking of the way that you interact. so that around PowerShell. I'll get into it in a minute on the limitations, but that thread kind of works throughout it all. All management pretty much happens over PowerShell instead of PowerShell commandlets for the most part, rather than other things that existed before. I've had to do a bit of patching projects just as I've worked through developing the ideas, and these demos in particular I'll be showing. So a little bit about the timeline of development. I think the first time I started playing with this was Tech Preview 3, and then I went 4 and 5 and a release to manufacturing. And those, in Tech Preview 3, the PowerShell command itself had maybe a handful of the normal options that it has. Trying to design things around what commands in PowerShell were going to be available in Tech Preview 3 was a little difficult. By Tech Preview 5, they actually got pretty much the full PowerShell command line, adding in different commandlets and pieces of PowerShell, and they're still developing it. So until after the release, a patch that they released after the release, there wasn't an easy way to download files. Invoke Web Request got added in as a patch about 2 weeks ago, I think, after the release to manufacturing. I also want to give a quick thanks. I doubt he's here, but one of the resources I've used a lot is a guy named Matt Rock, AdamWRock on Twitter. He's known for Vagrant, Packer, and WinRM, and has done a ton of work patching those things, and also a bunch of blogging around working with Nano server as well. And that was a huge help getting started. So some of the limitations. First, you've got no GUI, just PowerShell and command.exe. And that goes a little deeper. Most of the deprecated APIs in Windows have been removed. That's what breaks a lot of things that try to work. So not just GUI APIs, but also other deprecated system APIs and Win32 APIs. To reduce the impact of that a little bit, there are things called reverse forwarders. Those provide some APIs in a way that you can still run programs. They just might always work the way they used to. That makes it a little easier to get started if they're linked but not required. It's 64-bit only, so no 32-bit applications will work, and there are still a lot of them in the Windows world. No MSI, so a lot of packaging as it exists doesn't work. What you have instead is Windows Server Apps, which is an AppX packaging. That's pretty much a compressed package of a file hierarchy and a set of extensions around adding things like COM servers, WMI providers, and services. It has minimal configuration support, so there's none of the Active Directory service interfaces, no group policy. Most of that is done through PowerShell commandlets, or most of the same tasks that you would try to accomplish are. It comes with .NET Core CLR, but not the full .NET CLR, and so a number of applications, notably Chocolatey, won't work without some porting effort. One of the things that's useful in that is a list of deprecated functions that are still available. There's some other tools I'll get into later as well around that, but one of the tasks that I was doing was getting Factor running on it, and a number of APIs that it used weren't available. This list, I think, was the first easily accessible resource for figuring out which of those was causing trouble. And then, while everything's built around PowerShell, it is a little bit limited compared to full Windows Server or Windows Server Core. Some of the commandlets aren't present. Things like whatever I used to do for downloading files, new object, net client, isn't there. So PowerShell commandlets also C# objects. And many of the desired state configuration resources aren't available. So with that said, there's still some cool things you can do with it. And I'm going to go through some ways of getting started with Nano Server. The first one the first option we had in tech previews was a provisioning script that is shipped with Windows Server 2016. It's still there in the final release. And this is, if you're automating building these as Hyper-V images, this is probably what you're using, or what you'll use still. This sets up a VM with containers support, but otherwise fairly plain. Threw up a vagrant password. I will not be publishing anything based on that. Oh, and there's a mistake in it. That's fine. But one of the facilities that's built on top of that and present in the final release of server, or available as a standalone download, is actually the Nano server image builder. And this is a GUI wrapper around that command line, but it gives you a lot of visibility into what things are available, what extensions you can install, different ways to configure networking, all the things you might want to do while provisioning a machine. One of the handy things is at the end it'll also spit out the command line that it used to create the image, and so you can use this to figure out what command to use later on. It works on most new Windows operating systems, so Windows 8.1 Plus and Server 2012 R2 Plus. You can use the Hyper-V images on Windows 10 and Server 2016. I'll be doing Windows 10 just because that's what I had set up before. Another note, the Nano server images are also available in Microsoft Azure, and I believe there's a Microsoft demo tomorrow at 11 a.m. in the expo hall that will go over some of that portion of it. But in particular, the list of packages, I'll point out a few. This has DNS server, Hyper-V, file server, web server. It's pretty much the full list of packages that are available to provision on Nano server and bring in server roles. It may be extended with future packages that you can download, but I haven't really run into any yet. So for the next part of it, I want to make sure everyone's up to speed on what desired state configuration is. This is kind of a simple example of it that brings up a virtualized switch and a VM in Hyper-V. It's a very Puppet-like way of describing configuration in reusable scripts, and that'll bring up a VM with 512 megs of RAM, a single processor. The Puppet Labs DSC module works to wrap that and translates fairly cleanly over. This makes it easy to use DSC resources that are available, such as the Hyper-V management in Puppet. So I'm going to be doing a couple of demos. They're all available on GitHub at a PuppetConf 2016 page. The first one is just going to be bringing up a Hyper-V demo. And in this case, I'm using I'll be using DSC directly, and I'll speak to why in a moment, or speak to why now. So some of the things that I've run across on this. PowerShell 5.1, bringing that up, but PowerShell 5.1 brought in a number of substantial changes and broke a couple of things like the Puppet Labs PowerShell and Puppet Labs DSC modules, as well as an Xstorage DSC resource I was trying to use. They're all in the process of being fixed, but unfortunately weren't by the time I was going to do demos. So I want this one. So first one, I'm just going to give kind of a brief tour of Nano Server. I've set this up by enabling the Hyper-V feature on Windows 10, installed a Hyper-V DSC resource. So that's already installed, nothing happened. And then to prepare a DSC resource, you compile it by running the script. And then I'll apply the configuration there, and I'm going to have it print out some verbose output. You can see it's ensuring a switch is present, a VM is present and running. And then to connect, we'll open a PowerShell session. So the default way to communicate with Nano Server images is WinRM and PowerShell remoting. It'll take a moment to start up. So while it's fairly fast, yeah, that was faster than it usually is, actually. And so we have an image. This is not a clean one, but it is fairly minimal. So program files doesn't have a whole lot in it. 732 reverse forwarders. No forwarders. Those are a set of DLLs providing kind of the deprecated interface. And I'm going to go ahead and shut that VM down again using a fairly similar DSC script. So as far as Hyper-V goes, it's fairly simple to manage. You're more commonly, if you want to actually run Hyper-V images, more commonly probably going to run them on Windows Server, as it has better resources for managing it. But scripting it is fairly reasonable, and actually kind of seems like it should have a Puppet module. One of the other ways that I like to use images is via a virtual box or vagrant image. One of the primary reasons for that is that Puppet uses VMware vSphere, which imports VirtualBox images fairly easily. There's a set of vagrant boxes that Matt Rock published, as well as some instructions for how to build them. And then to connect to them, you still use PowerShell remoting. If you're on a Windows machine, you can use kind of some standard commands. If you're on a Mac or Linux machine, you can use a WinRM gem, a Ruby gem, to connect. I think for the sake of time, I'm going to not actually demo that. There's not a whole lot to it. So then probably one of the more interesting things, we'll talk about containers a little bit. So Microsoft describes containers as an isolated, resource-controlled, portable operating environment. To Docker, a Windows container can be managed in the same way as any other container. So on Windows, there are two variants of container, two types. One is the Windows container, which is what you'd more classically think of as equivalent to Linux containers. You're running on a single kernel, running containers in user mode, so sharing that kernel. And they achieve application isolation through process and namespace isolation. Hyper-V containers, which are the only ones available on Windows 10, are run on top of an optimized Hyper-V VM. And so they'll each have their own kernel. On Windows, Docker has been porting their tools, and so there's a Docker beta that now works. And is pretty easy to get access to. It has, one of the notable pieces is that it has a separate container runtime for Windows. So if you're running Docker for Windows, you're going to be switching between either using the VM to be able to run Linux containers or using the Windows container runtime. They have a blog post on that, announcing it last month, I think. The Docker on Windows supports file system layers, so it still optimizes how it builds up images from different layers. You can have it. They have Docker image registries, so Docker Hub has baseline Windows Nano Server and Windows Server Core images, and presumably others in the future. And Docker files work, among other things. Yeah, so one example of a Docker file for Nano Server. This one sets up Node, and it's actually built in a pattern called onBuild. So this first Docker file is the instructions for building just kind of a basic Node image. And so it downloads Node, extracts it, and then it has Docker files describing how to piece together an application on top of that. You end up building 3 different images, with the last one executing the onBuild commands and copying your files into place and installing them as a Node server. I'm going to do a brief Docker demo. So the way to set this up is a couple of commands. Is that readable? Yeah. The first installs a provider. And so this is a one-git provider. It's one-git is a PowerShell gallery, I suppose. It's a repository. It's a source for getting other packages through the PowerShell package management. I've already done that one. So the next, for Windows Server 2016, which is what I'm running here, there is a package for Docker already available. And this runs the Docker in the container runtime, not as Hyper-V containers. So with that already running, you can run Docker, see some Docker images. I have a bunch of things already set up because I didn't know how reliable the internet would be. But pulling down an image like the Nano Server image is pretty straightforward. And I have one extra step I'm taking to get Puppet available within that container. Because the Docker run on Windows has kind of a strange format with lots of colons, and I haven't figured out how to make it work with spaces yet. But here we have a Docker machine starting up that has Puppet loaded into the system, and so I can run factor, get pretty much all of my facts out. Right now it's reporting as a 2016 image. That may change. But for the most part, these make sense. You should have IP addresses available, all that. And some fairly simple Puppet code works on the system. And we get a notify. I'll be doing a little bit more on Puppet in a minute. But Docker makes one of the easier development environments to get started. And so mostly because of the ability to mount files so simply. And that's what I'll tend to use for the rest of this. But I'm not actually running a release version of Puppet. The first entry there is the packaging repo for a custom build that I did with a very minor number of fixes. For the most part, there are 2 gems trying to load up Win32 OLE and access some directory-related APIs that are no longer there that have to be made optional rather than failing out Puppet. The second link, oh, should have deleted that. That's the same demo link from before. If you're interested in more on some ideas around Docker, I'd suggest the modern infrastructure track, and I think Gareth Rushgrove has a talk tomorrow on it, where he'll reference Nano Server a little bit. And then finally, as an example of kind of the way the ecosystem around trying to build containers in Nano Server is developing, there's an issue for Kubernetes trying to get Docker or Windows container support into it. So trying to build up a environment where you can use Nano Server is still a work in progress. There's a number of different projects around it that have to develop further to be able to use some of the tools that we classically use. I'm going to show a bit more about where Puppet is in that life cycle. So what can we do with it? Things that work right now: file, host, exec. I think some other core resources, but I haven't exhaustively tested them. The reboot and ACL modules work. The PowerShell and DSC modules have some known issues that I think will be fixed soon. As with DSC, you can do a lot of the things that you might have done other ways. For example, the registry on resource in Puppet relies on some calls that aren't available anymore. The DSC registry resource is a stand-in for that. I think some of the work on developing Puppet is going to be rewriting some of those resources to work with Nano Server, either through Windows 32 APIs or possibly through DSC resources. I like this one as an example because long file paths have been a bane. And this is a very simple way to fix that I found out from Joey. So some things that don't yet work. Users and groups, since they require ADSI. The package, as there's no Apex support and MSIs don't work. And scheduled task, which requires a DLL that's not available. Also, one module that was pointed out to me is the IIS module, and we're going to get into that in a minute. The way you deploy IIS on a Nano Server is pretty much completely different from Windows Server. And I'm sure there are many other modules. So a few quick workarounds for people who want to kind of explore into this domain. There are PowerShell commandlets for creating and managing groups and users. So here's a exec to run using the PowerShell module that creates a group, creates a user using that group, creates a user, and then adds that user to the group. So I have a quick demo of setting up an IIS image. And this one, there's a couple ways to do it. So as before, when I was showing the Nano Server image builder, you can provision images that have IIS baked into it. If you're starting from a Docker container, that avenue isn't available. Instead, you have to get the packages from currently the server ISO and install them to the Docker container. Instead of doing that, though, or to make that easier, I have a Puppet manifest that will go through those steps and set up the IIS image. This is not as polished as the image build stuff shown this morning. I wish I could have gotten a chance to try and do that and make it work. the Windows support is not there yet. But this is creating an unattend file that will use DISM, a way to install packages to take that package for IIS, install it, and get the service started. And then once we have that, we can see we can take a look at the Docker container that's running, get the network address from it, and not have that work. That's fun. Have an IIS server running. What that ran is fairly Puppet manifest that did that is fairly straightforward. I'm declaring the unattend file, and so this defines packages that will be installed. Lay it down somewhere, run PowerShell with DISM to install it, making sure that it's immutable, and then start the service. So some of the basic tools that we use to configure Windows still definitely work on Nano Server. Some of the specifics have changed, and that's going to be a challenge for writing reusable modules between Windows and Windows Nano Server. One I don't have a solution for. Now, one of the other questions left is packaging. So the AppX package, I'm going to show an example of that as well, is defined by a manifest. Most of this manifest is defining the identity of whoever's distributing it and providing a secure, or providing a way to verify who it comes from via some package signing. The additional piece in here is a service. I don't know that this actually works yet. I was having some issues with it, so it's a step towards it. It needs some tweaking. But the process of creating that package then, I'm going to be using an installation I've already extracted on this system to create a package from. Eventually, we'll actually be generating some AppX packaging, but for the moment, a pipeline around that isn't available. But the way this works is you add a manifest and a logo, and then run a utility that comes from Windows 10, the Windows 10 SDK, to make an AppX package. And I already have one. There we go. Now, signing the package is going to require a key. And for the demo, I've created a self-signed key. And there are steps for that documented. So there's a link in the GitHub repository with notes for these demos. But I'm going to just show the commands as well. And that should be finishing up in just a second. There. So we'll be making a new key. There's a make cert command. This generates a public and private key. We use that to generate another file that I'm not really sure, I haven't really looked into what it is, but it's a necessary part of the process, and then use it to sign the application. So this administering these is done with a couple of PowerShell, or installing these is done with a couple of PowerShell commands as well. I'm going to bring back the VM, the Hyper-V VM I used in the first place, copy over the application, so the AppX package, and the certificate used to sign it, because I need to make sure that my machine will trust that package. So I'm bringing up that VM again. So the AppX package is going to install to an application spot in C program files. It's getting that on the path or getting that available in some easy way to find isn't something I still need to figure out. And now I think we have an instance of it taking slightly longer to start than before. There we go. So on the machine itself, since I have a self-signed certificate, I'm going to be importing the certificate I provided to say that this is a trusted certificate, and then install the package. And so there's a set of commands: add AppX package, get AppX package, and remove AppX package for managing these. So we can see it now recognizes there's a package installed. It has a bunch of metadata around it, as well as we have the package installed there. I'm going to go ahead and remove it again and move on. So I'm just getting the full name. If you try to remove the AppX package with the short name, it doesn't work. So that was kind of a whirlwind of how to work with Nano Server. Some of the things that are available, I showed a Puppet manifest you could run, but a lot of the pieces work. I'll work on providing the steps to build the application for this are publicly available. I will see if I can provide the Puppet agent package itself that I've created. So some of the ways to get started using that, you can use Hyper-V directly on Azure, generating your own images, use Docker, which is probably the easiest one for me from day to day, and use Vagrant machines or VirtualBox. Areas for improvement to start using these are the PowerShell and DSC modules in Puppet, and a number of other Puppet modules, core resources. Right now, the set of applications that work are fairly limited as well. So Node will run, the Git will run, which is excellent. There are definitely others that don't yet. Trying to run Vim doesn't succeed at all. One of the things I skipped was showing psedit. So there are ways to remotely edit text files on Hyper-V images using psedit if you're running Windows PowerShell ISE. I want to note briefly some of the resources that I used getting started on this. Hurry Up and Wait is Matt Rock's blog, and that has a lot of material as well. And then Alessandra Pelotti of CloudWork did a lot of work testing out Puppet, and also around supporting has his own work around supporting Hyper-V images on OpenStack. So thanks. I have a couple minutes for questions.
Okay.
So when you had I noticed when you started to build that package, you built it from program files, like the actual Puppet directory. Is it intelligent enough to know that, hey, go look and figure out that was installed via an MSI? And how does that work to know about the services that it needs and everything else in the package? Or did you have to do some special magic fairy dust?
Yeah, it doesn't know to go look for pieces in the MSI. There are tools for extracting files from MSIs. That is potentially one of the ways you could start modifying existing packages to try them with AppX. The way we will want to go is definitely generate our own with getting knowledge of servers or services and anything like that. That was definitely a step where I'm taking existing knowledge and adding it.
Any other questions? Going once? Twice? Okay. Thank you, Michael.
All right, thanks.